any element that can neither give out electron nor gain electron is termed to be unreactive chemically. You already know can also be called inert gas, it can also be called rare gas, and it can also be called unreactive element. Now, within the 1 to 20 elements, the noble gases we have are helium, atomic number 2, we have neon, atomic of number 10, and we have argon, atomic number 18, within the first 20 elements. By electronic configuration using atomic shells, we have the K, L, M, N atomic shells. All these are just reminders. According to Nievre, K can accommodate maximum of 2 electrons. L accommodates maximum of 8. N can take about 18. N can take about 32. We get this by this general formula 2n squared, where K is the number 1 shell, this is the number 2 shell, number 3 shell, number 4 shell, and so on and so forth. We're able to use this formula to get how many electrons, these are electrons, how many electrons each of this shell can accommodate. Okay, we're able to get how much electrons can be filled in each atomic shell. But by octet rule, we're able to know the pattern for filling of electrons, which is in the order of duplets, starting with 2 electrons and what now? Octets with what? 8 electrons, until the atomic number for that element is achieved. Until the atomic number, don't forget. So looking at helium, helium is just atomic number 2, so it takes 2 electrons for the K shell, which is completely filled. Then let's go for neon. Neon is atomic number 10, which takes 2 and 8. Instead of drawing the cycle, not to waste time. Then for argon, we have argon 18, which takes 2, 8, 8. You must fill it in this pattern of duplet and octet until the atomic number is achieved. Let's add up 2, 8, 8. 2 plus 8, 10 plus 8, 18, which is the atomic number for argon. Now, since we already have a completely filled shell, 8 and 8, therefore, noble gases are unreactive because they cannot give out electron, neither can they gain electron. That is the meaning of the unreactivity. Any element that can neither give out electron nor gain electron is termed to be unreactive chemically. Why? Because it cannot combine with atoms of other elements to form a compound. For this level, I said it last class, according to your level, we see noble gases to be unreactive because at this juncture they can neither give out electrons nor gain electrons to form any chemical compound that you are familiar with. But at advanced level, there are other reactions they can undergo, but we are not going to call it chemical bonding since we don't have any ions or free electrons to give out or to gain. This was where I stopped in the last class. Now let's pick up elements. Subheading now, let's write. For other elements, wait to subheading is this so we can write the story order. Let me tag it compared, determining, okay, determining compared and lone pair electrons for elements of elements. Determining paired and lone pair electrons of elements. Let's make that subhead. We are going to be making use of all these ideas for chemical bonding. So how do we determine the unpaired and the lone pair electrons for different elements. I'm going to show you now, and I'll give you some examples, and you'll try one or two yourself, so you don't have to cram it. Everything we are learning is based on atomic number and electronic configurations. Once you can know the atomic number for any element and you can share the electrons correctly, you would know how many unpaired and how many lone paired. Unpaired means single. You can start by writing that: unpaired, single electron in an orbital. Single electron in an orbital. That's what I mean by the unpaired. When you have a single electron in an orbital. Single electron in an orbital. That will give us the unpaired electron. It's very simple. Paired means two. Like your shoe now, you are wearing a pair of shoe, right? Yes, you can't wear unpaired shoe to school. Something will happen on the road. Is it that dog pursue you? Or government agencies will pursue you that, and you are walking majestically with just one pair of shoe or one pair of slippers. Yeah, you can't do that. But when we talk about pair, they have two electrons maximum, put it like that, maximum of two electrons in an orbital. Maximum of two electrons in an orbital, which must spin in opposite direction. Spin in opposite direction. Spin in opposite directions. Maximum of two electrons in an orbital, which must spin in opposite directions. That is what we mean by pair electron. Alright, so when you hear the word unpaired electron, single electron and orbital. Now what is orbital? Let's be breaking it down like that gradually. When we talk about orbital in chemistry, it is different from shell. Atomic shell is just this, which is labeled K element. But atomic orbital, we use this small rectangle, this box. This is an atomic orbital. This is atomic shell. Orbital, small rectangle. Don't have to be too big. That's an orbital. Now, how do we label the sub-levels of atomic orbitals? We have sub-levels of atomic orbitals. Sub-levels of atomic orbitals. Please be jotting everything down. Be happy for jam. No, you already know my class now, so I don't need to advertise it. I already know how it's rolling. I teach based on what you need, now and after. I'm giving you salient knowledge. So when we enter past question, like we always do, it's 10 questions, 20 questions after each class. By now you should be scoring 18 out of 20. Of the same topic, not random topics, the same topic, chemical body. We'll pick 20 questions in a PQ and you see it. Alright. Sub-levels of atomic orbitals are labeled S, P, D, F. Atomic shell, K element shell. Orbitals, S, P, D, F. Sub-levels, okay? Sub-levels. Sub-levels. Just be jotting this jam class. It's not why nobody's writing stories. Salient points. Now, these sub-levels, there's something we call degenerate orbitals. Be watching the word though. This is orbital. This is sub-levels of atomic orbitals. Then we have degenerate orbitals. Degenerate orbitals. Now, X does not have a degenerate orbital. So it's just one orbital. One orbital, no degenerate orbital. No fold. No fold. S does not have fold. It does not have degeneracy. It does not have spatial orientation. Any English way they call out for you in future. Somebody can just ask you, how many spatial orientations does the p orbital have? You will know it today now. D has a spatial orientation. F has spatial orientation, or we call it folding, or we call it degeneracy. But X does not have a fold. There's nothing like you build bungalow now, and you call the bungalow because you have upstairs. Now say it's a story building. One story building means you must have a building first before another building on top. Not one building you call story building. I don't understand my point. If you have a building now, then you have another building. That is a story. Another one on top, 2 story. You are not counting from down. So X is just the first orbital. So there's no fold. Alright. But P has 3 sub-levels. I mean 3 folds. 1, 2, 3. 1, 2, 3. P has 3 degeneracy. 3 folds. P has 3 folds. Now the clue is this. Do you know odd number? Talk to me now. Do you know odd number? Yes, sir. After 3 will be what? After 5 will be what? 7. Thank you. So that's the order. That's the order. So D has 5. Like we just answered in a 1, 2, 3. 1, 2, 3, 4, 5. 5 fold. D has 5 fold. Then you've already answered the number F. F has 7 fold. Did you come to learn that? Please borrow me. 1, 2, 3, 4, 5, 6, 7. 7 fold.